We are going to continue with our analytic methods that will allow us to eliminate the factor that's giving us 0 over 0 when we are getting 0 over 0 from direct substitution when evaluating a limit. Meaning, the next question I want to try is, what is the limit? And I'm going to leave space so I can write the title of this in just a second. What is the limit as x approaches 0 of 1 over 2 plus x minus 1 over 2 all over x? So I'm going to plug 0 into the numerator, and I get 1/2 minus 1/2. The denominator, I get 0. So what I hope that you notice is this is another case of 0 over 0. And when looking at the function, I notice that I have fractions inside fractions. So that makes me think, get an least common denominator and simplify. And I'm specifically thinking about the top. So if I look at the numerator, I have 1 over 2 plus x, and I have 2, meaning my LCD would both, for this function, would have both a factor of 2 and a factor of 2 plus x. So as I am looking at the function, this first fraction right here is missing a factor of 2. So I'm going to multiply the bottom by 2. And in multiplying the bottom by 2, I also need to multiply the top by 2 so that I'm not changing any values. I'm only multiplying by 1. For the 1/2 to get a common denominator, I need a factor of 2 plus x in the denominator. And so I'm going to multiply the top and the bottom by 2 plus x. What this gives me is the limit as x goes to 0. And I know I'm going to have a common denominator of 2 times 2 plus x. Actually, I'm going to show you one in-between step. And this isn't a step that I would expect that you show me, but I think it might help you see it a little bit better for this first time. So I have 2 over 2 plus x minus 2 plus x over 2 times 2 plus x all over x. And that's this x here, just coming down, just traveling down. So now I am subtracting with a like denominator. So I have the limit as x goes to 0. These problems are big. Of 2 minus 2 plus x all over 2 times 2 plus x all over x. And I'm going to write that as x over 1. And the reason I'm going to do that is I recognize that I am dividing two fractions. And I know that when I divide fractions, I multiply by the reciprocal. So the next step, I'm going to clean up just this. If I have 2 minus 2 plus x, I'm going to distribute the x, distribute the negative, and I get 2 minus x. This gives me 0. So I end up with negative x over 2 times 2 plus x all over x over 1. So now I just have division between fractions. It's as simplified as I can get it. I suppose I could distribute that 2, but I don't need to. So now I'm going to change it. I'm going to change the division to multiplication by the reciprocal. So I have negative x over 2 times 2 plus x times 1 over x. So I flipped that and changed it to multiplication. Now I hope you notice that x divided by x is just 1. So I get the limit as x goes to 0 of negative 1. Don't lose this negative sign. That's an easy thing to lose in the question. And if we plug in 0, so now I can finally use direct substitution. If I plug in 0, I get negative 1 over 2 times 2, which just gives me negative 1/4. So now to run through those steps again, we determined what our LCD was. We created the LCD with both fractions. we actually subtracted the fractions and cleaned them up. And then we cleaned up the division by multiplying by the reciprocal. We divided out the common factors, watching our signs, and then we used direct substitution. All right. And the last method, so this was, did I write it down? Yep, I wrote it down. The last method, I'm going to call expand and simplify. So this one, I'm going to find the limit as h goes to 0. Notice the change in variable of x plus h cubed minus x cubed all over h. So the first thing, with that change in variable, it just means when I'm using direct substitution, I'm going to plug in 0 for h rather than x. So that would give me x cubed minus x cubed all over 0, which is 0 over 0. So I'm still getting 0 over 0. I just didn't get it with numbers necessarily. I had some variables after I plugged in 0. But moving on from there, what I want to do next is I want to expand x plus h cubed. So I'm going to do some side work with that. So let's see if it will let me move it over. There we go. So x plus h cubed means I am multiplying x plus h times x plus h times x plus h. Let's multiply two things together at once. So I'm just going to bring that down. And then x squared, or x plus h times x plus h is x squared plus 2xh plus h squared. Now you have options. You can either use double distribution, so you can take x and distribute it to each of those, and then take h and distribute it to each of those. So you're going to end up with 6 terms and then combine like terms. Or, depending who your Algebra 2 teacher was, sometimes teachers use a box just to help organize. That's your other option. And I will be honest, I don't care which option you choose whatsoever. It's whatever makes more sense to you. So x times x is x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. One recommendation I do have is to put the variables in the same order so it's easier to see like terms. So if in some terms x is first and in some terms h is first, it might be confusing. But if you notice here, I have 2x squared h and x squared h, and then xh squared and 2xh squared. So there are your like terms, and so we can add those. If, depending on your pre-calc course or the course that you took before this class, you may have learned binomial expansion. You can also use that. That's completely fine. But if you didn't learn it, you can just multiply it out. That's completely fine. So coming back to the problem, we now have the limit as h goes to 0 of x cubed, and then 2x squared h and x squared h is 3x squared h plus xh squared plus 2xh squared gives me 3xh squared, and then plus h cubed minus x cubed all over h. So now we, I hope that you notice x cubed minus x cubed, those just cancel. So I have 3x squared h plus 3xh squared plus h cubed, all divided by h. Now I hope that you notice our goal in all of the 4 techniques is to divide out the factor that's giving us the 0 over 0. So in each case, we're hoping to eventually get to the point where we can cancel something, the factor that's giving us the 0 over 0, so that we can end up with a function that we are able to use direct substitution with. So if you Notice each of the terms in the top have a factor of h. So if I take out the h from each term, I am left with 3x squared plus 3xh squared plus h squared. Now I can divide the h's to get 1. And that gives me the limit as h goes to 0 of 3x squared plus 3xh squared plus h squared. Now I'm finally to the point where I can plug 0 in for h, which means everywhere I see an h, I'm going to make it 0. And that just leaves us with 3x squared. So in this case, our answer is a function of x rather than a number, and that's completely fine. This particular question is going to end up being important later in another chapter, so it's good that we're kind of working with this now. Please try the practice assignment, and if you have questions, please let me know. Shoot me an email. I hope that you are having a great week, and I will talk to you soon.